Hello, Sukaya. Good
Yes,
evening.
sir. Good evening,
Okay, what's the question?
sir. Same to you.
Okay. Working of transformer with the help suitable diagram and obtain the relation between the input and output voltage, number of primary turns, secondary winding, output, and a setup transform convert a low voltage to the high voltage. Does it not violate the principle of conservation of energy? Okay. The transformer is basically is based on the mutual induction on the Faraday's law, right?
Yes.
You know the working of a transformer? Have you read it?
No, sir. We don't talk about it.
Okay, let me discuss the transformer.
Okay.
One second. Transformer. Actually, it is based on the Faraday's law. We can take a coil, and in this you know the meaning of a coil. Suppose we have a two coils. We have a circuit. Let me use the different color pen and decrease the line size. This is just some circuit and some voltage source, some AC voltage source. Okay,
Okay.
and here we will use the coil. Okay, this is the coil in which we flow the current because of this source. Suppose the potential of this is Vp. Vp means the voltage of primary coil. Okay, across the primary coil, and these are some suppose n number of turn. Okay,
Okay.
n number of turn in the coil. If suppose there are n or suppose that it is np, a number of turn in np, then we will connect this. Uh, use the another phone. Okay, then we will use the another coil and we connect it like suppose we have a secondary. This is our secondary coil. Okay, here the number of turn is different. Let the number of turn here is ns. Okay, so
Okay.
there is some flux when the current go in this. There is a flux in this coil, right?
Yes, sir. Yes, sir.
Okay, there is a flux produced in this flux. Do you know the meaning of flux?
Yes, sir.
Product of magnetic field and the cross section or the area. The change in area or the change in magnetic field because of change in magnetic field or change in area, we produce the
Flux.
flux. There is a change in the flux. So here we have a magnetic field. If the current go in this, suppose if we look from the here and the current flow clockwise in a clockwise direction, then
Okay.
it should be north pole or south pole. It should be north pole, right?
Yes, sir.
Because the magnetic field will go like this
Yes, sir.
in this direction. Okay, then this is the north pole. We treat it as a north pole, and when there is a change in the magnetic field or magnetic field and then magnetic flux, then uh, the magnetic fields of this also change, and we place a soft iron core here.
Yes,
We placed a soft iron core. One second. Like I connect this primary coil to to this coil by some soft iron core. Okay,
okay.
this is some soft iron core having some medium. This is soft iron core. Okay,
Okay.
because of this soft iron core, the flux also changed. Okay,
Okay.
with a high value, and here the voltage across this voltage of this is Vp.
Okay.
Vp. Okay, and because of the change in the magnetic flux, EMF produced in this circuit, and because of EMF, there is an induced current flow in this circuit. Okay,
Okay.
here we produce the induced EMF. The value of this induced EMF is minus d5 by dt. Okay,
Yes, sir.
this flux, that is change in flux here. Okay,
Yes.
so by Kirchhoff's law, let's do it on the next page. By the Kirchhoff's law, we can find the value of the Vp. It is equal to Ep, the voltage across the primary source. Okay, and the
Okay.
value of Vp is connected to the flux. This is how connected to the flux. This is equal to Vp is equal to potential across the primary coil is equal to the number of turn of the primary coil, and then d5 by dt, that flux, change in flux with respect to time. Okay,
Yes.
similarly in case of the secondary, ef or es or vs, suppose this is es voltage across it, or induced emf across it is minus d5 by dt. This is the emf. Okay, this is the emf across the secondary coil, so it is equal to ns d5 by dt. Okay,
Yes, sir.
hello.
Yes, sir.
Okay. Hmm. So secondary coil is a open circuit. This secondary coil is a open circuit, and the output at the two terminal voltage output at the two terminal. Here we connect the voltage output or the two terminal of the battery can be calculate. Okay, we can calculate this. Okay,
No.
by the, so there is a relation, we call it, one second. Yes, this is a relation between the ES and EP. This is a ratio, ES and EP is equal to the number of turn and NS upon NP. So we can fix the voltage across the secondary coil and the primary coil by changing the number of turn in the secondary and the primary coil. Okay, so for step up transformer, if we have to increase the voltage across the secondary, then what we have to do, we have to set up the number of turn of a secondary coil very large in comparison to the number of turn in a primary coil. Like this is the formula, ns upon np into ep. Okay, so when will call transformer as a step up transformer, when ns is greater than np, right? This is a set up transformer, right? And in set down,
Yes, sir.
hello,
Yes, sir. Yes, sir.
yeah, in set down it will be
NP is
np
greater
greater
than.
than. Okay,
Mm. Okay.
np, when np is greater than ns, this is set down transformer. Okay, obtain the relationship between the output voltage in terms of the, yeah, this is a relation. This is a relation you ask. This is a relation. If you
Okay.
divide this with this is also equal to the ep. Okay, if
Okay,
you
sir.
divide this and this, you will get this equation. Okay,
Okay.
is it
Okay.
clear to you?
Yes.
Okay, okay, bye.